Hello, hello. This is meeting number 34 of the Visual Tools group. Only some parts will be made public later on, probably. And we have a few topics today, slightly overlapping. All of them are kind of related to our hope of creating user-friendly, easy tools in the browser to explore Clojure, and also other ways to explore Clojure in a more convenient way. And so there are some overlaps, and a few people here have been exploring these topics, and that will be presented in a moment. And we actually had some great conversations in the last few days about at least a few of these. Maybe could we begin with Alex? Maybe Alex, you would say something brief about yourself and about your topic that will be at the end of this meeting.
Sure, no problem. Hi everybody. My name is Alex. What can I tell you about myself? I've been using Clojure on and off for maybe since about 10 years ago, uh, actually with some commercial use and also my own projects as well. And My talk and demonstration today is going to be focused around a proof of concept that I built uh, for working with the Clojure stack, um, doing notebooks and data science, etc. in the browser. The original use case was for EdTech, that's educational technology platforms, to basically help people learn about um, doing data science. So yeah, the first point, yeah, what have I built? What was the motivation and the origin story? Um, so yeah, this is like a personal story for me really. Back in January this year, unfortunately, I got made redundant from a data engineering role, um, which I was very much unprepared for. And In between interviews and such, I've been trying to brush up my skills and pick up new ones in the areas of data engineering and some machine learning stuff and AI stuff as well. Um, and in my sort of research on how to do online learning, I came across something called Data Camp, which you may or may not be aware of. I'm just going to share my browser window. Can my screen should be shared now? Is that working?
Yeah,
Okay, that's great. So, oh, okay, great. So, can everyone see? I'm in data camp.
yes.
Okay, so don't want to not going to say too much about data camp. There's various ed tech, educational technology platforms out there where people can, do courses online for all kinds of things. Data camp's kind of specifically focused on um, online learning for data engineers, data scientists, etc., etc. And it's organized into courses and tracks. And the general idea is that you follow some material and it checks your understanding by asking you some questions. And it's interactive, so you can run code when it works. Is it actually going to work? Uh, I think, yeah, this might have, okay. Yeah, that might have, it was working earlier. I'm not sure what's happening. But yeah, anyway, you can run code, interactively, and you can submit your answer, and then it will check, the DataCamp platform will check uh, what you've done, if you've got the correct answer to the problem, and a little bit of source code inspection to see how you've done it as well. Um, and this includes, text output, but also like notebook style um, sort of questions as well, where you can visualize data in the browser. So that's great, but what's not so great is the fact that Clojure is not supported on these platforms at all. I couldn't tell you why. It's probably because it's kind of like, fairly niche. They tend to focus on more popular languages and tools. But unfortunately, without Clojure being available, all of the wonderful work that's been done making Cycloge happen isn't available. And other things like learning about functional programming, for example, is not so strong on these platforms because the languages supported aren't really suited for functional programming. So anyway, whilst I was doing my data camp, brushing up my skills, I and noticing that kind of being a bit sad, felt was a bit sad that Clojure's not supported. I began to think, well, what would it take to provide a something for Clojure that would work in the same way, where it asks you questions, you're writing code in the browser, and then you can evaluate it, and some platform can check the result based on what's expected, and maybe examine your code, etc., etc. So I wrote up like a I guess it's more like a just explaining the rationale, the motivation, just for my own reference and like sharing the idea with people. So here I'm just basically talking about why it would be beneficial to have Clojure support on some of these platforms because of the recent the growth in the recent years. The kind of like feature parity with the what you can do on Python. You can do, I think, pretty much a lot of the same stuff now is possible. So that was kind of like the use case where it's kind of also focused on like no setup. So just coming back to data camp, you're immediately jumping into thinking about the data problem or data science problem that you need to work with, like loading the data. I'm assuming here we're talking about like a data set, like delimited text or whatever. What are the columns? Doing statistics. You jump basically. It's like bootstrapping users straight into so they can focus on whatever it is that they're trying. The course material is about. So anyway, that's the origin story, the motivation. The next step was I started to think about, well, yeah, what would it take to actually make this work in the browser? And initially, I was thinking just about the REPL and being able to, edit code, evaluate it, and get the results back in the browser. Of course, the constraint here is if we want to use Cycloge, it's really we're talking about the JVM because that's the the libraries are all using Java for the numerical stuff to get the performance we want. And so, but we need to run it in the browser. So how's that going to work? We're not going to expect those libraries to be available in ClojureScript, for example, anytime soon. So if you want to use the stack, we need a JVM. So when I actually did my research and I approached this work, it's important to know at that time, which was back in March this year, I wasn't actually aware of the WebAssembly stuff at all. Had I been, I might have changed my thoughts on, what to build or how it might look. But anyway, that's just the order that I explored things in. So, given that we need a JVM, I'm thinking, okay, there needs to be some kind of, server part running a REPL, and then we've got a browser, something running in a browser with an editor, some way to see the results, etc. So it's like already I'm thinking, well, that's two things. And some key technologies for me to understand are nrepl, because I decided that that's given the features I need. If for interactive programming, Clojure programming from the browser, that seemed like a reasonable choice. And then how am I going to communicate with it with a REPL from the browser? So what I did is I posted, I think this is back in February, without actually mentioning what it was for at the time. But basically, yeah, this was like the beginnings of my research into what already exists in this space. For REPLs running in the browser, basically. And what I discovered in this post here, there's a few things that I found, existing things, but for one reason or another, none of them kind of exactly fitted my use case. So, for example, I'm talking here about something I found called Weasel, which is more for kind of like a Clojure script use case. And yeah, my use case was slightly different. So essentially, I've got something that's JavaScript based, sending a message. Another technology choice is how to do the communication. So there's some trade-offs here. Looked at WebSockets, HTTP. Decided to go with WebSockets. Since doing that, I've learned a bit more about what the trade-offs are there, but it seemed like a reasonable choice at the time. And then we've got, the things that happen on the server are pretty much standard REPL Clojure things. There's not too much to say about that. And then we send the reply back. And then, that's at that point, it's just data. So it's up to the client to decide what to do with the data. And then I've got this little diagram here that kind of I drew at the very early stages of what I was investigating, to try and, before I built anything, just to try and visualize when I'm asking for people for their opinions, what my options might be, just to check that there's nothing out there already, or what other people thought of ideas in this space. And what happened is, in the thread, I got some useful responses, and one in particular gave me an idea about basically having a WebSocket proxy over an nrepl, over a REPL, and that was enough to make me think, okay, maybe that's something I can try and build just as a proof of concept to see whether it would work or not. Initially just doing REPL interaction and viewing the results as text, and then if I can get that working, then how much effort would it be to extend that to doing the main goal, which is using Clojure with it, and visualizing the results as tabular data, charts, etc., etc., etc. All the things that Clay supports. So that's the research side and the sort of like the investigations that I did. Then I started building something. So I can give a demo of it. So yeah, the front end is very rudimentary. I'm not a front end developer at all. There's lots of things that could be improved here. But the point here is really just to kind of like look at the feasibility of it, and then have discussions like this about sharing ideas, trade-offs, what works well, what doesn't, and possible next steps. So basically, what we've got here on the left-hand side, we've got an editor component. So this is actually, I'm just going to go to my README because this talks about that. Yeah, so we've got on the left-hand side, it's like an code editor. So there's something called Code Mirror, which is like a JavaScript editor widget, code editor widget, supports various languages, one of which is Clojure. Sort of fairly basic support. And then there's something called Clojure mode, which extends Code Mirror with additional features specific to Clojure editing, so such as structural editing and syntax highlighting. Yeah, you can kind of see that. So I don't know if you can kind of notice here, like if I do that, I get the matching paren. You can probably see that the parens, are underlined when they're just to sort of help you navigate. So it's just basic stuff. There is actually Clojure mode has like extra support for more detailed support for structural editing like slurp bath, etc. But I don't think I've enabled it here yet. And other things like selection, structural selection of text, etc., etc. So that's the editor. The result is actually another editor widget, but it's just read only. So I get the syntax highlighting, printing, etc. Yeah. So we've got multiple modes. I'll talk about that in a bit. But if I hit eval, probably helps if I actually change something. Hit eval, yeah, it does what you'd expect it to do. I've got the console open on the right hand side, just so you can see some of the communication. So the WebSocket stuff is literally just serialized as JSON. Again, seemed like a reasonable choice. There's other possible options, but just went with something simple. And if it does what I need, then that's fine for a proof of concept. Yeah. So yeah, and as I said, so basically I got this working. There was a bit of work to support namespaces. But yeah, it's essentially just nrepl operations like eval, loading a namespace, creating loading namespaces, just proxied with this WebSockets wrapper, and then the response from an nrepl operation can be delivered in multiple parts, and the last part will have the status of done. So what I've got a transducer to process that data, which supplies the result when it sees done. So this is for when you might have data coming back that you've got more data and it's being sent in multiple parts. So yeah, and next thing to talk about is these modes. So the REPL mode was like the first thing I got working. And then what I did is I thought, right, well, what's needed to, bring clay into the picture? So the REPL that's being proxied on the server, it's got like a fixed class path essentially. So for the EdTech use case, the idea is that each user would be getting like a container that would be managed on some cloud platform somewhere, that's already set up to go with the required libraries like Nodge. I think in my case at the moment it's not the full Nodge set of dependencies. It's a smaller set, but yeah, you could use that instead. And yeah, so if I cycle the modes to, I'll just do clay initially. So yeah, what we've got here, the result here, how this is rendered depends on the mode. So for REPL mode, it's just a reagent components. In clay mode, this is an iframe inside the reagent interface. So the server, when it starts, it's proxying a REPL, but then it's also starting clay as in a server mode as well. So that's just automatically available. And yeah, if I I can eval again, and it just does what you'd expect. So the idea here is that for newcomers, you can get straight into the data science problems or data exploration, no setup. So people can get to the the interesting bits that they want to get to pretty quickly, like drawing some pretty pictures, understanding the data. So they get like the reward pretty quick, and then it's like, if then you tell them, okay, well, yeah, you don't have to, if you want to, if you're a power user, yeah, you don't need the browser. Then you can install the standard development stack. That would be like the way, the sort of the general idea here. The other thing to show while I'm here is the different like modes of evaluation. So eval evaluates like the whole namespace or file. So this is actually what's happening in the background is the server is writing this content out to a temporary file, and then that gets passed to ClayMake. But what you can also do is you can, as you'd expect with a Clojure editor, you can eval like individual parts. So the eval button just evaluates everything, but via the keyboard shortcuts, I can just evaluate parts. The final mode to show, which is actually the one I added first before the iframe, is the clay hiccup mode. So what's happening here is Clay actually has an experimental API where instead of being passed a file and rendering the whole file and serving that via its web server, it just returns the data, the HTML data, as hiccup data. And yeah, I mean that's what you're seeing here. So if I do, so I don't know if you noticed there, the response came back much faster, because yeah, it's just working with the data rather than using the clay to render the whole file. Okay, so what I'll show now is yeah, come back to REPL mode, and I'm gonna get Yeah, so basically, just as my sort of test was that for this of is it ready to demo yet? Was can I load and run the Noj getting started tutorial? Because that was like a minimum sort of like use case for sort of just demonstrating it like more fully. So I'll just load that in. Oh, yeah. So here's one I prepared earlier, so to speak. But then I can, eval, each of these forms. So typically, this is where you're kind of, building out a notebook, to explore a data set. And each time you do something, um, you can inspect it. So where we've got something like this, we can go, okay, well that looks interesting, but I can't really, it's hard to understand what's going on here. Oh, but I've got clay mode. So if I evaluate that, it's the clay rendering just for this component. So we've got, it repeats the code that's being run and then prints the results in a way that we can more easily see what's going on. And continue the idea. So I'm just eval each individual parts, and then I can see the results. Or come back to REPL mode. And then it's like, oh, okay, so here we've got some kindly annotated data. It's a chart. So back to clay mode, and we've got a chart. And I should be able to eval the full notebook. Yeah. So this is like a typical use case for the whole notebook. And this should match, this output should match. If you go to this particular page online, the output should be the same. So this is like where you can kind of like do the educational piece around data science with Clojure without the the fiddly bits. And then again, like the hiccup mode works for tabular data and charts. I've added support for those. I think other things probably won't work, but there's a few trade-offs. Like out of the box, I don't get the style sheets. You can kind of see here, there's no style sheet, doesn't work, but the charts work. As you can see, it's a bit faster than rendering the whole notebook. Okay, so that's kind of the current state of what I've made. Next thing I was going to talk about, the trade-offs. So this is where it gets kind of more interesting, I suppose. So an obvious trade-off here, is it requires a server. Because the JVM is running elsewhere, because basically you haven't like reduced the amount of complexity of the stack of things, the arrangement of things in order to make this work. It's still the things are all the same. They're all the same. They still exist. You just moved it around and kind of hidden it from the user in this case, who is a newcomer. It's the use case of a newcomer. So that's an important thing to sort of mention. As opposed to with WASM, again, that's like a serverless approach. It's going to be more efficient. There's associated costs. If this is a container running on a cloud platform somewhere, and each user needs one, whilst they're following their courses on, educational courses. There's associated costs with that. That's worth considering. But then, as we saw with WASM earlier, there's the other trade-offs, like was discussed. The missing features like networking and concurrency. So, for example, in this notebook, one of the first things we need to do is networking to get the data. So that's something to consider, I think. So that's kind of like some of the trade-offs. And like, for example, with WASM, I'm thinking what didn't get mentioned earlier is, like, what about interactive programming in the REPL? For example, in Clojure 1.12, there is a new add lib function, which lets you dynamically add libraries whilst you're working on a project. And there's a use case for that right here. So this code, I actually lied earlier. When I said it was the Noj getting started guide, it's not exactly the Noj getting started guide. It's had some tweaks by me to make it work. I won't go into the detail of that just now, because I'm just conscious of the time and I've run over a little bit. But yeah, like, I've had to require Java time. The stock class path for I could change the stock class path for the educational ed tech use case. I could say, okay, what's the stock class path? Well, I don't know. I mean, it needs to include Noj, but what else? And it ends up needing to be the kitchen sink, because you don't know what the use case is. I mean, for ed tech, you're setting the problems. You know what the problems are because it's part of the course. But even then, people want to add courses. What's the class path? So this is where things like add lib is useful. But then, that's quite an advanced feature. Making that work in WASM, I'm not sure about that. And just generally, there's quite a lot of complexity in Noj and Clay, getting that working, so we can render notebooks. It is, possibly would be quite a lot of work. Well, might be some blockers there. I think. Oh, potential next steps. So as I said, it's a proof of concept, which is like, the bare minimum. The next steps might be a prototype, but a prototype of what? That's a product. Well, products have requirements. This is where it might deviate from the ed tech use case, because that's what I was kind of keep trying to stay focused on, that use case, because if you start thinking of other use cases, it's just an explosion of requirements. So I tried to stay focused, but I had talked to a few educational technology platforms about this stuff, but they don't seem to be particularly interested. I couldn't tell you why, because they didn't reply to me. But it might just be that the size of the community is not quite there yet, and the amount of use. But hopefully that will change. Hopefully that will grow. But in terms of features, they're like awesome. Obvious ones are, the editor could do with. There's a lot of things that could be done in the editor. For example, linting with Condo. I believe that's actually possible. I think the author of the Bashka has got that working. And using the same editor component that I'm using here, so I don't think that would be too difficult to add. Things like code completion, I think would be feasible via the nrepl operation for that, but that's not done yet. Yeah, and then like more structural editing support, which as I said, I believe is supported. I've just not enabled it. Yeah. So that's kind of some possible next steps.
Thank you, Alex. Thank you so much. Yeah. This is good news, this project, and actually it is something that a few people have been trying to do during the recent year, and somehow you connected a few of the pieces in a way that looks like the right way to go in a pragmatic way. Maybe just for context, I'll say to the other friends here that it is part of this effort to make tutorials, specifically data analysis, data visualization, to make the tutorials very accessible. And the problem is that there are those different rendering pathways that you were demonstrating, and that a few people are now having lots of work on making the different rendering pathways compatible. And part of your effort was to overcome that, the fact that, rendering through reagent or as static HTML is not exactly the same at the moment with this kindly standard that we have. But we're getting there. And what it means, I think, is that what you said is that the same tutorial that is available as a static web page will be an interactive tutorial. And the WASM pathway is promising for, further along the way, maybe, but for now it cannot do what everything we need, of course. And that is why it is good to have this client server approach. And yeah, I know we are a bit over time, and I really appreciate it that you could present today, like on a very short notice, and Andre and Roman and Shagun, who had to leave. And thanks, Siavash, for staying with us. Yeah, Alex, it felt like you had a little more to say, and I stopped you earlier. Maybe you wish to conclude or say a little more.
There was one thing that I forgot to mention, but I put a note about it in the chat, which was other similar products. Next journal is definitely worth a mention, because what I demonstrated is very, very similar. Yeah. Although I think the main difference is, well, I mean, the kind of back end as a service cloud idea, they've kind of implemented their own version of that. And when you're presented with the notebook evaluation screen at the bottom, it's got runtime. So there's, this is the JVM, that's your private JVM being made available for you. But yeah, I think they're using Clerk rather than Clay. And I specifically wanted to use Clay, I think, because it seemed like a convergence of ideas, and I particularly liked the standard, the kindly standard, where the data can be visualized in lots of different tools using the same standard, which kind of moved me to thinking, more to use Clay.
Yeah, I think you're right. The point is the standardization. And yesterday on the conference, we had Anton, who gave a talk, did demonstrate another pathway, which is Google Colab, that also now almost supports the same standard we're talking about, the kindly standard. Yeah, and maybe that belongs to another call we have. All of these were just beginnings, and I really appreciate again everybody for those helpful talks, and we'll keep chatting hopefully. And really thank you so much. And in a moment we should say goodbye. Yeah,
great. Thank you.
Yeah, much appreciated. So take care everybody, and see you hopefully on the next times.